So I just want to go over this question you asked me about. This is the 1988 AP Chemistry free response question, in particular part C. So the first thing you want to realize about this question is that it gives you information about the antimony trichloride before equilibrium is reached and afterwards. It gives you the information here. It says a 1 mole sample of antimony trichloride is first placed in an empty 2-liter container. So that tells us what the concentration of antimony trichloride is before it reaches equilibrium. And then later on, it tells us that the number of moles of antimony trichloride should be 0.700 mole. And since we know what the volume of the container is, that tells us what the concentration of antimony trichloride is at equilibrium. So again, if we calculate the concentration initially, we see that it's 0.5 molar. At equilibrium, it should be 0.350. Again, because it tells us that we use 1 mole of antimony trichloride in 2 liters of 2-liter container, and we also know what the number of moles of antimony trichloride is at equilibrium with the same volume. That gives us the concentration at equilibrium. So then what we do is we set up our ice table, and you can see that I've inputted the concentration of antimony trichloride initially. The other thing you want to realize about this is the equilibrium will shift left in this case, because all we're presented with is a certain amount of antimony trichloride in the reaction vessel, and the reaction must shift left in this case to reach equilibrium. So initially the concentration of antimony trichloride is 0.5 molar. When the equilibrium shifts left, the amount that it will change we can define as minus X. The initial concentration of chlorine in the vessel is some number of moles over 2. Now again, that's what the question's asking for. It's asking for the number of moles of chlorine, which we can just write as N in this case. The change for chlorine will be minus X, and the amount of antimony pentachloride will be X. At equilibrium, of course, the concentration of antimony pentachloride will be X. The concentration of antimony trichloride will be 0.500 minus X, and of course the concentration of chlorine will be N divided by 2 minus X. At equilibrium, we know that the concentration is 0.350 molar. And what that does is that allows us to figure out what X is. X in this case is 0.150. That also tells us the concentration of antimony pentachloride is. We also know that that's 0.150. With all of this information, it allows us to calculate what the concentration of chlorine will be at equilibrium. Using our equilibrium expression and using all the known values, we can calculate that at equilibrium, the concentration of chlorine will be 0.050 molar. Now, down here in my ice table, I see that the concentration of chlorine at equilibrium will be N divided by 2 minus X. Of course, I know what X is. I also know what the concentration is. It's 0.501 molar. So I can plug that into this equation and calculate what N will be. Just doing simple algebra, we see that N divided by 2 will be equal to 0.2 molar. And of course, N then is equal to 0.4 molar.